On October 24, 2003, a white Delta-winged aircraft touched down at Heathrow for the last time. Thousands of people stood on rooftops and along fences at the airport perimeter just to watch it land. Concorde had been flying paying passengers across the Atlantic in 3.5 hours since 1976. After that afternoon, it never flew again. For the next 22 years, nobody on Earth could buy a ticket to fly faster than sound. Not because the physics stopped working, because the business never did. That's the part most retellings skip. Concorde didn't fail because supersonic flight was impossible. It failed because supersonic flight, the way Concorde did it, was a machine for turning fuel into noise and losing money on both ends. If you want to understand whether Boom Supersonic's Overture is actually going to succeed where Concorde didn't, you have to start with exactly what killed Concorde. Because Overture's entire design is a direct answer to that autopsy, item by item. Concorde itself was never supposed to cost what it ended up costing. Britain and France signed the treaty to build it jointly in 1962, splitting development between British Aircraft Corporation and Aerospatiale, and the original estimate for getting it into service ran somewhere around 150 to 200 million pounds. By the time Concorde actually entered commercial service in 1976, the real bill had climbed past £1 billion, something like 10 times the original number, and neither government ever recouped it. Concorde wasn't a product that happened to run over budget. Its economics were broken for the first paying customer ever boarded, and everything that came after was airlines trying to make an already unprofitable machine survive contact with fuel prices, noise rules, and eventually a fatal crash. Start with the engines. Concorde flew on 4 Rolls-Royce Olympus turbojets, and to punch through Mach 1 it used afterburners. Reheat, in British terminology, dumping raw fuel into the exhaust stream to get a last shove of thrust. Brian Trubshaw, the British chief test pilot who first flew Concorde in 1969, climbed out of the cockpit after that flight and told reporters it had been wizard, a cool, calm, and collected operation. He wasn't being paid to worry about the fuel gauge. Somebody else at the airline was going to have to be. Afterburners are simple and they work, and they are also spectacularly wasteful. Concorde burned roughly 6,700 gallons of fuel on a typical transatlantic run for around 100 passengers. A modern subsonic widebody carries 3 to 4 times as many people on the same route and burns a comparable amount of fuel doing it. Concorde's economics were never close. Airlines could only make the math work by charging fares that put the airplane permanently out of reach for anyone who wasn't flying on an expense account. And even then, profitability was thin and route dependent from the start. Then there's the noise, and this is the constraint that actually shaped where Concorde was allowed to fly at all. Break the sound barrier, and you don't just make a bang once. You drag a cone-shaped shockwave behind you continuously, and everywhere that cone sweeps across the ground, people hear a boom. Loud enough, done often enough, over the wrong terrain, and it cracks plaster and rattles windows. Regulators in the U.S. banned civil supersonic flight over land in 1973, years before Concorde even entered commercial service, specifically because of boom complaints from military supersonic testing in the decade before. Concorde was built to cruise at Mach 2 over open ocean. Over land, it had to throttle back to subsonic speed, which meant its one real advantage, speed, only existed on a handful of overwater routes. London to New York worked. Almost nothing else did. Add one more fact that isn't really an engineering problem, but mattered anyway. On July 25, 2000, an Air France Concorde blew a tire on takeoff from Charles de Gaulle. The tire debris ruptured a fuel tank, and the aircraft went down 2 minutes later, killing all 109 people aboard and 4 more on the ground. Concorde flew again after that, with reinforced tanks and Kevlar lining. But the fleet was already old, already burning cash, and the crash gave 2 airlines carrying a shrinking, jittery premium market exactly the excuse they needed to stop. British Airways and Air France retired their fleets within months of each other in 2003. Nobody has flown a paying passenger past Mach 1 since. So that's the list. A wasteful, gas-guzzling engine. A shockwave that made most of the Earth's surface off-limits at speed. and a business model so fragile that one bad year could end it. Boom Supersonic's Overture is engineering choice by engineering choice, an attempt to answer all three. Take the engine first, because it's the one piece of the airplane Boom doesn't fully control, and it's also the piece that has already ended a rival company. Overture's engine is called Symphony, and the headline detail is what it doesn't have: no afterburner. Symphony is a medium bypass turbofan, four of them, purpose-built to push the aircraft through the transonic region and up to a cruise speed of Mach 1.7 without dumping raw fuel into the exhaust to get there. No reheat means dramatically better fuel burn at supersonic cruise than Concorde ever achieved, and it means the engine can run on 100% sustainable aviation fuel rather than requiring the low flash point, specially formulated fuel Concorde needed. Boom didn't design Symphony alone. It assembled a consortium of partners, because no established engine maker would take on the program outright. Rolls-Royce, the company that literally built Concorde's engines, explored a partnership starting in 2020 and then walked away in the fall of 2022. That detail matters more than it sounds like it should, and we'll come back to it. Boom's founder and CEO, Blake Skoll, has been blunt about why he didn't go looking for a second big engine maker to replace Rolls-Royce instead of assembling his own consortium. "We made a strategic decision that we wanted to own and control the design of the engine," he said, "and this is something that you see really every successful new entrant in aerospace doing." The consortium he put together instead splits the job three ways. Florida Turbine Technologies handles the core engine design. G.Eng. Additive contributes manufacturing know-how for 3D printed engine components. And Standard Aero, a company with decades of experience maintaining military and business jet engines, signed on to handle Symphony's maintenance and overhaul once it's flying. It's a capable roster. It is also not a single established engine giant staking its own reputation and balance sheet on the program the way Rolls-Royce did for Concorde, or the way GE and Pratt & Whitney do for every subsonic airliner flying today. Next, the airframe. Concorde was aluminum because in the 1960s, that's what you built supersonic aircraft out of. And aluminum is heavy, and heavy means you need more thrust, which means more fuel, which means more weight in fuel in an unforgiving loop. Overture's fuselage and wings are built predominantly from carbon fiber composite, the same category of material that let modern subsonic jets like the 787 cut structural weight by double-digit percentages over their aluminum predecessors. Lighter airframe, less drag-inducing bulk, a design that doesn't need to fight its own weight just to reach cruise speed. It's not a novel material choice anymore. Composites are standard on new subsonic airliners, but nobody has flown a supersonic composite airliner yet. Overture would be the first. Now the part that's genuinely new: physics-adjacent engineering. Not just a materials upgrade, the sonic boom problem, and Boom's proposed answer, which they call boomless cruise. Here's the actual mechanism, because it's the single most interesting piece of this whole story. A sonic boom doesn't travel to the ground in a straight line. It travels through air of varying temperature and varying wind speed at different altitudes. And both of those variables bend sound the way a lens bends light. Fly fast enough, high enough, under the right atmospheric conditions, and the shock wave refracts, bends upward, back into the upper atmosphere, and never reaches the ground at all. This isn't a theory Boom invented. It's a known atmospheric acoustics effect called Mach cutoff, documented since supersonic military testing in the 1960s. What nobody had done was fly a civilian aircraft that deliberately threaded that window at a controlled speed and altitude and proved the ground stayed quiet. That's exactly what Boom's demonstrator aircraft, XB-1, did over the Mojave Desert in early 2025. It's a third-scale test jet, roughly the size of a business jet, built specifically to prove out Overture's aerodynamics and engine integration years before the full airliner exists. On January 28th, Boom's chief test pilot, Tristan Brandenburg, climbed XB-1 to just over 35,000 feet and pushed it through Mach 1 3 times, the first civilian-built aircraft to go supersonic since Concorde retired 22 years earlier. Blake Scholl's line afterward was that a small band of talented and dedicated engineers has accomplished what previously took governments and billions of dollars. Then, on February 10th, Brandenburg took XB-1 back up and broke the sound barrier 3 more times, for 6 total across the 2 flights, while ground observation teams and microphone arrays confirmed no audible boom reached the surface on any of them. Mach cutoff demonstrated on a real aircraft over American soil, legally. Boom's plan for Overture is to fly at Mach 1.3 over land using that same window, and up to Mach 1.7 over water, where there's no population below to worry about anyway, and the aircraft can simply go faster. If that holds up at full scale, and holding up at full scale is a genuinely open question, not a settled one, it solves Concorde's second problem directly. An Overture that can legally cruise supersonic over land isn't restricted to ocean routes. Suddenly, the addressable map of viable supersonic routes isn't a narrow strip between coastal cities. It's most of the planet. But Boom isn't the only one working that problem, and it isn't even the one with the power to actually change the law. That 1973 overland ban is a federal regulation, and only the FAA can rewrite it, which is exactly what NASA has spent the better part of a decade building a separate airplane to make possible. The X-59, developed with Lockheed Martin's Skunk Works, is a single-seat research aircraft shaped specifically to keep its shockwaves from ever merging into one sharp crack. Instead of a bang, the goal is something closer to a soft thump, engineered down to around 75 perceived decibels at the ground, compared with roughly 105 for Concorde. NASA's job isn't to sell tickets. It's to fly the X-59 over American communities, measure exactly how people react to that thump instead of a boom, and hand that data to the FAA. The agency has already proposed replacing the flat 1973 speed ban with a performance-based noise standard instead. Regulate how loud you're allowed to be on the ground, not how fast you're allowed to fly, with final technical standards targeted for around 2027. Boom's Mach cutoff and NASA's shaped boom research are 2 different engineering answers to the same underlying obstacle running on parallel tracks. And Overture's business case over land depends on one of them actually landing in new federal rules before the airplane is ready to use them. Which brings us to the third problem, and it's the one that's specific to supersonic flight, rather than aviation in general. Not just whether Overture can be built and sold profitably, but whether the fuel and engineering premium that supersonic cruise demands can ever be small enough for a fare that isn't Concorde's exclusivity all over again. Here, the honest answer is nobody outside Boom's own finance department actually knows yet, and plenty of people who've spent decades in aerospace do not believe the numbers work. The company most worth mentioning here isn't Concorde, it's Aerion. Aerion spent 17 years and hundreds of millions of dollars trying to build a 10-passenger supersonic business jet, partnered at various points with Airbus and Boeing, and shut down in May 2021 for one specific, boring reason. It ran out of money before it ran out of engineering problems, and no engine manufacturer would commit to building its power plant on Aerion's timeline or budget. Overture's engine situation looks uncomfortably similar on paper. No major engine house, not GE, not Pratt and Whitney, not Rolls-Royce after its early involvement, has signed on as Symphony's sole developer. Boom is functionally self-funding a chunk of the engine program itself through a consortium of smaller partners, which is precisely the kind of arrangement that drained Aerion dry. The dollar figures involved are not small. Boom's own public estimates put the total cost of bringing Overture to certified commercial service somewhere between $6 and $8 billion. As of 2026, the company has raised a bit over $600 million. That's a real well-funded startup by most standards, and it's also a fraction of what the program says it needs. Scott Kirby, the CEO of United Airlines, one of Overture's own launch customers, put the odds at 50-50 in public remarks. Industry analysts who've watched supersonic programs come and go have been blunter than that. There's one more number worth putting next to Concorde's because it's the clearest sign of how differently Boom is trying to play this. Concorde carried around 100 passengers, and its fares ran multiples above ordinary first class, a symbol of exclusivity as much as a mode of transport. Overture is sized for 64 to 80 passengers, all business class, with a design range of roughly 4,250 nautical miles, enough to connect most city pairs across the Atlantic and Pacific without refueling. Boom's own stated target isn't Concorde's ultra-premium price point at all. The company has repeatedly said it wants Overture fares to land in the same range as today's ordinary business class tickets, not above them. Whether that promise survives contact with a real balance sheet, 4 engines, and a $6 to $8 billion development bill is unproven. But it's a deliberate repositioning away from the exact trap that made Concorde a luxury curiosity instead of a real transportation option for more than a sliver of the flying public. And yet the order book is real, not speculative marketing. United placed an order for 15 overtures with options for 35 more back in 2021. American Airlines followed with an order for 20. Japan Airlines both invested in Boom directly and placed its own order. Boom finished construction of a dedicated final assembly plant in Greensboro, North Carolina in 2024, built with capacity to produce 33 overtures a year once the line is running. None of that guarantees the airplane flies commercially. Airlines routinely place conditional, cancelable orders on unproven aircraft as a hedge, and options are not the same as delivered airplanes. But it's a very different level of institutional commitment than any supersonic program since Concorde itself has managed to attract. The current plan has the full-scale Overture, not the small XB-1 demonstrator, the actual 64 to 80-seat production airliner, beginning flight testing around 2027, with certification and the first paying passengers sometime after that, likely toward the end of the decade. Every one of those dates has already slipped once from Boom's earlier public roadmaps, which is worth remembering because every previous attempt to bring supersonic travel back, and there have been several since Concorde retired, announced dates that slipped, then slipped again, then quietly stopped announcing dates at all. Here's what makes Overture different from those earlier attempts, and it isn't marketing. It's that Boom has already done the one thing none of its predecessors managed. It put a real aircraft into supersonic flight without a sonic boom reaching the ground, using regular airspace under existing regulations, with instruments running and observers watching. That happened. It's not a rendering, it's not a simulation, it's a flight log. Whether that same physics scales cleanly from a lightweight, 1/3 scale demonstrator to an 80-seat airliner carrying 4 Symphony engines in a cabin full of paying passengers is the actual unanswered question the entire program now rests on. Concorde's problem was never proving supersonic flight could happen. It could, obviously. It flew paying customers for 27 years. Concorde's problem was proving it could happen without losing money and without a boom that got it banned from most of the sky. Boom has, on a small scale, already shown both of those constraints can be engineered around. Whether that holds true at full size, on schedule, without the funding gap that sank Aerion, is the only question left standing between the runway at Mojave and a passenger cabin. For 22 years after Concorde landed at Heathrow for the last time, the fastest way to cross an ocean got slower, not faster, because the industry chose subsonic economics over supersonic speed and never looked back. Whether that era is actually ending, or whether Overture becomes one more supersonic prototype that flew once and never became a business, is a question nobody, not Boom, not United, not the engineers who've been trying to solve this since the 1960s, can answer yet with a straight face. What's different this time is that, for a few seconds over the Mojave Desert in early 2025, somebody actually flew the answer to see if it worked. The ground stayed quiet.